Okay, number 11 on your practice test here. The number of bacteria N in a culture is modeled by the following. N equals 200 times e to the kt, where t is the time in hours. If n is equal to 360, 1t is 4. What is the time required for the original population to quadruple in size? Okay, this is something you have to develop a little intuition when you look at these kind of problems first. The idea of when we have this right here is that this 200 will always be the original amount of bacteria that you have. Okay, let's figure out why I know that right away. Because it's saying t is in time of hours. So if at the original time, that means t is 0. So again, I just want to talk about my initial population here first, so you can you can understand what this 200 stands for here. So the intuition again is that t is 0. So that's my initial. I'm looking for my initial population when the time is 0. Okay, e to the 0. So this is going to be 200 times e to the 0. Anything to the 0 power is 1. Therefore, my population is 200. So that's my initial population. So you should always think of that number. When you look at that number in the front, that's my initial population. And that's our original population. We want it to quadruple in size. So our goal is to figure out what t is when n is 800. The problem we have right now is we don't know what k is. So we know eventually we want to find t when n is 800, but we don't know what k is. Well, we can use this information right here to figure out what k is first. So right here, if n is 360, then t is 4. So let's go ahead and plug it in here. 360 equals 200e to the k times 4. Okay, now we need to solve for k. So we're going to divide both sides by 200. 200 to cancel out. 360 divided by 200. The zeros cancel out. 36 over 20. That's just going to be 1.8. E to the k times 4. Okay, again, I need to get rid of that e. Get the inverse of an exponential function. With a base e will be the natural logarithm. So now I'm going to take the natural logarithm of both sides. So those will cancel each other out. The natural log of 1.8 equals, I'll just write this as 4k. So k is going to equal the natural log of 1.8 divided by 4. Let's go ahead and put that in our calculator here. Natural log of 1.8 divided by 4. So our k in this problem is 0.147. A lot of work to find the k, but you got to find the k here if we're going to now use it back in the original equation now. Now we know k is 1.147. We're going to put that in here. We know n is 800 because we want to quadruple the initial population, which was 200. So let's go ahead and solve for this now. So 800 equals 200 e to the 0.147t. Okay, I'm going to divide by 200. Okay, so you should notice something right there. So if I'm looking for like quadruple the size, that number is going to become 4. So 4 times the original number. So if it asks for something like where you double in size, this number should be 2. Here again, now we got e, so we're going to take the natural log of both sides. I'm going to skip a step there. So again, I took the natural log. So all that happened was the exponent just came down and have the natural log of both sides. So natural log of 4, and then I'm going to divide by 0.147. T equals natural log of 4 divided by 0.147. So natural log of 4 divided by, divided by, we'll just use the answer up there. So answer is 9.434. And we can see the answer is B. Okay, so we can see that these problems, a lot of these problems are very, a lot of number intensive stuff here. But all you're doing is you're just solving for one variable, just like how you would solve it, in algebra 1. But now we have these exponents. Just remember the inverse again of exponential functions is the logarithmic, and an inverse of the logarithmic is the exponential. So that's how you get rid of them as needed. Again, you need to isolate them as needed, just like how we isolated it here. Again, we got rid of that constant in the front. We isolated it. Then we could do the natural log right there.